The next thing that somebody usually says after that explanation, which is quite reasonable at first, is that, well, if I put an open interval just about anywhere, right, let's just say here, for instance, okay, and you map that up to the curve, won't that produce a lowest or highest value automatically every time, rendering basically the definition vacuous, right? It doesn't really have any special meaning if you can always do this. So let's just draw this and see what happens, okay? So this particular open interval, which I claim has no relative max or min within it, right? Okay, we'll map it up here. Right, there it is. So we're looking at this particular subset of function values across this open interval subset of the domain. Is there a lowest value or a highest value within this stream of function values? So usually, I'm going to give some values now just to make this a little more concrete. So we'll say that this is, let's say 1, 2. We'll say this is 2 here, okay? And then this one up here ends at 3, perhaps, all right? So what we're doing now is we're looking at this set of function values which corresponds to the open interval 2 to 3, right? So we're looking at this connected interval of function values from 2 to 3. Is there a lowest value on the interval, again, these function values, from 2 to 3? And it's an open interval. So the first thing a person usually says is 2 is the lowest and 3 is the highest. So therefore there's a relative max here and a relative minimum here. The problem with that is 3 is not included in the interval, neither is 2. So therefore you can't claim 3 is the largest value here because it's not here. Nor can you claim the smallest value is 2 because 2 is not in this interval. So you can already kind of see why this is phrased in terms of open intervals. If you used closed intervals, then certainly there'd always be a relative max and relative min on that interval, right? But when you use open intervals, there's not necessarily so. So the next thing people usually say is, well, if the highest value is not 3, because it's not in here, then it must be the number right before 3, right? So then I would say, what is the number right before 3? So then people usually say 2.9 with a line over it, right? 2.9 forever. They usually don't say that first. Usually they say 2.9, and then I bring up 2.99, and they say, oh, it must be that one. And I say, well, about 2.999, and so forth forever. So you can always, in a sense, find another number closer and closer to 3 without ever reaching 3. But then there's this one, 2.9 with a line over it, and then people will say, well, that must be the one right before 3. The problem with that is that 2.9 with a line over it is actually the number 3 itself, right? Now that may not be so obvious at first. You can easily prove it to yourself with a little bit of algebra. I'm not going to do it right now, but the main point is there is no number right before 3, so therefore there is no highest value on this open interval of function values from 2 to 3. There's no highest value here because you can always just push yourself closer and closer and closer and closer to 3, right? That is, you can always push yourself closer and closer and closer to 2.9 with a line over it. All right. Anyway, the same thing works going the other direction. If a person says, well, I see that 2 is not the smallest here because 2 is not even in this set, agreed, but maybe 2.1 is the smallest number in this interval. Maybe 2.1 is, the number right before 2 on the right-hand side of 2, right? As you're going down towards 2, maybe it's 2.1. But then, of course, I will answer with 2.01, and the person might say, okay, it's that one, but then, of course, there's 2.001 and so forth forever. So because you can just have this 2.1, and then you have 2.01, and it's a little bit clear on this side that as you keep moving further and further, right? So 2.000001, how many zeros are you going to tack on, right? And then you're going to claim there's a 1 at the end. Well, that's impossible. You can't claim such a thing. So therefore, it's clear on this direction that you're never going to reach the number, right after 2, because there is no number right after 2. This is a property of the real number system in general, is there's always a real number between any two real numbers. So there is no number closest to 2 here on the right-hand side of 2, so therefore there is no smallest function value on this interval, and this is why the whole idea of relative extrema is phrased in terms of open intervals.